Welcome to Season 2 of Grey Matter Talks Tech, a podcast for devs and IT enthusiasts looking for useful insights from industry experts. I'm Robin Ashby, Embarcadero licensing specialist here at Grey Matter. I have the pleasure of hosting today's episode and am excited to welcome Embarcadero's Stephen Ball and Antonio Zapater to discuss the benefits of native app development. Welcome to the show, guys.
Thanks, Robin.
Yeah, thank you. Thank you for inviting us.
That's okay. Before we get started, could you each tell of our listeners a bit more about yourselves and Embarcadero? Let's start with you, Stephen.
Sure. Hi, everyone. My name's Stephen Ball. I'm the pre-sales director here at Embarcadero. Embarcadero is part of the Idera group. There's must be around about 30 or so brands now within the group, which is fantastic because it gives us a real collective mix of things across a wide range of tech within the dev tools space. I think we've got around about 12 or 13 brands just within the dev tools division, spanning BI tools to low-code development tools to the native tools that we have with Embarcadero, JavaScript tools, Essentia, and so on. So it's really good because we get a pulse across a broad range of what's going on within the industry. I joined Embarcadero originally back in 2011 and worked as a pre-sales team member. I've been the senior product marketing manager. I've been a product manager for Interbase, and now I have the pleasure of kind of leading the DevTools pre-sales engineers across the Idera group.
As Robin just said, my name is Antonio Zapater, and I'm a pre-sales consultant, in this case specifically for Embarcadero. And I joined, I was about to say that recently, but it has been 2.5 years already. But yeah, my background is primarily development tools. So I know pretty much all the Embarcadero tools to the very, very specific detail. And I'm helping customers to understand and to squeeze every single feature from our products. And also I go to multiple events, as the one we did in London. And now I'm heading to Amsterdam as well, to the Delphi Summit, and multiple other events around Europe.
Thanks for that, guys. Thanks for the intros. And for joining me on this episode. So today we're going to be delving into why developers should consider native app development. So my first question is, what exactly is native software development, and how does it differ from cross-platform or interpreted approaches?
It's a great question, Robin. So I think the key thing really here is, let's pick up on the word native first and foremost. So there's lots of different platforms out there. If it's Windows, if it's Mac OS, if it's Linux, iOS, Android, there's quite a few. They're the primary ones, really. A native application is one that runs on the operating system. And the key thing here is that as a native application, you can then connect into any of the APIs on that platform and interact directly with the hardware and work directly to the metal. And the key value for that is always around speed and performance and security. They're the three things: it's speed, performance, and security. Speed, because you're directly to the metal, you can directly push things to the CPU or the GPU accordingly to whatever you need to do, which gives you the best performance. Security, you haven't got extra layers like runtimes. For example, you haven't got a .NET or Java runtime that's in the middle. So it's a layer that people can't modify or mess with. Speed, security, and kind of the underlying performance that provides. And one of the things that we've seen a lot is that there's a big push around green IT, and being able to get directly to the metal as well just gives you fewer clock cycles potentially, compared to having other things that are running in the middle that are interpreting things back and forwards, which is kind of expensive and time consuming. So it also means that you can scale up a lot more with that hardware than you would do if you had other layers running in the middle. So hopefully that kind of gives you a little bit of an idea about how they're different. Now, the other part that you mentioned was how they're different to interpreted approaches. I think one of the great benefits of Java and to an extent .NET is that you've got a runtime that you can put across multiple platforms, and then your code can run to that runtime, and then the runtime's then sorting out the layer down to the platform. Where we're different is we actually provide a single code base, and because we have the compilers for each of the platforms, you don't actually need to worry about having those interpreted layers. So what that means is that you can almost just copy and paste your applications from your development machine onto the target platform, and they're going to run. When you've got interpreted approaches, you need to make sure that you've got the runtimes installed and everything is there before you then put your application on top. And if you have different applications that are running with different versions of the same runtime, then that can be quite a challenge at times as well. So I think that's probably the main difference. Anything you want to add to that, Antonio?
I mean, you explained pretty much what I would have said. The only thing I would probably add is when we're talking about interpreted languages, we can also include others like JavaScript, Python, or PHP, for example. With .NET and Java, you kind of compile the application, even though you still need the runtime, as you just mentioned. But with Python and JavaScript, you cannot compile, per se, the application into a kind of a binary DLL or something like that. A lot of people think they do, because there is this term, for example, for TypeScript applications that they say, yeah, I'm compiling my website, but that you're not really compiling. What you're doing is transpiling and obfuscating your source code to don't make it too obvious. For example, if you have JavaScript and you have a website, the client or the user that is accessing the website will literally download and have on their computer the JavaScript source code. What you can do is, of course, as I said, is obfuscate it to don't make it too obvious to read, etc. But it's doable. With a native application, the whole thing is compiled, and you do need to have way more skills to even think about analyzing a compiled application. We're talking about reverse engineering and very, very, very advanced topics. So that's also, as you mentioned, security. But I wanted to add as well this note about languages that are not, the concept of compiling is not what a lot of people think it is.
Thank you for that. So how does native development impact application speed and responsiveness in comparison to frameworks that use virtual machines or runtimes?
Well, the main one is performance, because you can think about it as layers. The less layers you have between the hardware and your application, the smaller the latency you can experience with the application. Let's get a website, for example. There are some technologies called, for example, like capacitor or ionic. They are using pretty much the same. But what you're doing is you're embedding in a mobile application a website. You get the icon, you download it from the store, but conceptually it's just a website embedded in an application. That's going to be running your application on top of a browser, which means we have more layers to access the actual CPU and the GPU, etc. And also you're going to be limited by whatever that browser lets you access to the mobile. So, for example, if you don't have a good camera API, you're going to have you will need to be fiddling with how to access or to bypass the browser to access the native camera that your phone will have. So one of the main benefits is, or direct benefits that a user can experience, is performance. A native application will always be more performant than an interpreted one. I'm talking specifically about mobile applications, but this translates as well to computers or even to services. Now it's very popular to have Electron applications on computers. And Electron, just for people that don't know, it's conceptually the same thing I just explained. It's an application that runs a website or using web technology as a desktop application. It's not also responsiveness, but we're also talking about resources, which is the bit that really annoys me personally. Because if you go and analyze the amount of resources that these applications use, is ridiculous compared to what you will get with a native application. For example, the other day, just to talk about the case that I experienced myself, I was struggling with the RAM used on my computer. And I found that one of the Chrome extensions, because all the extensions are coded primarily using JavaScript, it was using 150 megabytes of RAM, an browser extension. So that's the level of very poor use of resources we get with multi-platform technology. I know it's very appealing from a developer perspective. I code once and then you can use it anywhere. But there are better solutions to that. For example, we have on Brad Studio, we have FileMonkey, which you aim specifically for which platform you want to compile. And we compile natively the code for that platform. So you get a very optimized application. You code only once and deploy to the platform you're aiming for. Same thing for Windows, same thing for macOS, Linux, or even mobile applications, macOS and Android. I don't know if you want to add anything else extra, Stephen?
No, I think you kind of hit, I think, the main points there. Obviously, the whole point with kind of having the ability to cross-compile to multiple platforms is that you can get all the benefits that you get from a single code base, and the reduced development times. If you get a bug in, you're likely to be fixing it from multiple places. It can reduce down the amount of QA cycle that you need to take. But getting that look and feel for each platform, getting that speed and performance for each platform, is something that you can readily achieve with something like FileMonkey and with the FileMonkey framework that we use through Rad Studio. And yeah, when you are looking at trying to get something out and get the benefits that you need to make sure that especially where people got bring your own device profile policies, that you need it on Android, you need it on iOS at the same time, that you can deliver that, but you also need to deliver the security and the speed and performance. And we say, the resources. I know if you look at there's one of the technologies that's .NET based for doing mobile, and when you're running it on Java on Android, you've not only got the garbage collector running in the background, which obviously then isn't freeing memory up straight away. It's periodically doing it, which is eating up resources. But you've then got underneath the .NET runtime garbage collector, the Java garbage collector. So you've got two garbage collectors running at the same time, which is terribly poor use of resources, especially on devices that haven't got a lot in the first place. So there's a big reason to go native. And if you look at all the apps in the app stores, in terms of the top performing apps, they're all native apps. There's very few that will be written using a scripted language. And that's why you want to kind of make sure you get native.
Thanks for that, Stephen and Natalie. So how have modern native development tools evolved to address the historical pain points like cross-platform compatibility?
Yeah, so I think if we look back at Delphi's history, so I think within Rad Studio we've got Delphi and we've got C++ Builder, but the Delphi framework gives us the broadest coverage in terms of platforms, and originally it was built to be the best tooling for developing on Windows, and today still a huge part of our customer base is about developing on Windows, and the runtimes that are part of the language, the IDE, have been written and expanded over time to now ensure that when you're calling the APIs that we've used to wrap the Windows API, those same APIs are doing the mapping to the individual platforms that you're trying to target. So, for example, you might call one of our system classes to get a file path for a specific file. And when you're calling that API through your code, you just call the API. The code itself is then mapping to the individual platforms to a version of it for the platform that you're compiling out to. So it'll then take care of making sure that everything is running correctly on the individual platforms that you're pushing to. And that evolution over time has ensured that we have got source code now that people wrote 30 years ago that you could open up and recompile and take advantage of getting that directly onto iOS and Android, platforms that never existed when the original Windows development was initiated and taken forward. So I think that evolving has been fantastic at foundation layer. But then also when you look at what the VCL, the Visual Component Library within Rad Studio, has done for Windows, and how that's been almost copied. The guy who wrote it originally, Anders Hillsbury, who went on to Microsoft and became the father of .NET ultimately, and the WinForms implementation, which was heavily influenced through the VCL. There's been modifications and updates to that, which then has been the basis for what FireMonkey's become. FireMonkey is very much not a clone, but a very, very close sibling to the VCL, which allows for some different paradigms, parenting of controls and so on. But that evolution has made it a lot easier to work with generics and other language features that have come in over the last 20 years or so. So we now have something that's very easy to work with and very easy to transfer skills between kind of the native Windows development and getting the true native Windows experience, and taking those same skill sets and being able to evolve those directly across to a cross-platform environment where everything you do is based on everything you've learned already. So even a developer who's been developing for 20 years on Windows is going to be able to get a mobile application done across to iOS and Android natively very, very quickly.
Thanks for that, Stephen. I know you mentioned a little bit earlier about security advantages of native applications, but what specific vulnerabilities are reduced compared with interpreted options or web-based applications?
The first one I would say is not providing your code or part of your code directly to a final user. When I'm deploying applications, I tend to have zero trust when I'm sending my applications. So I want them to be as secure as possible, because a lot of things can go wrong once you're not the one deploying your own applications. And as I mentioned earlier, with interpreted languages, not with all of them, as I said, with Java and .NET, you kind of can compile those. But the fact that final users are going to have access to some of the code, even if it's obfuscated, that's a major problem, at least for me. And I think it should be for most developers, because you're showing ways to connect to your backends. You're showing you need to pay a lot of attention, for example, to security for API tokens, and it's a very, very adds a lot of complexity to your project. I'm not saying that every single project should be native. I'm gonna be fully honest here, because of course it makes sense that you have a website and then you need to have a good layer of security on your website. But we're in this situation at the moment that it looks like every single developer wants to go multi-platform with these new technologies available, and they don't think they only see or look into the benefits, and they don't analyze the potential risks as well. So that's something that we need to have a sit down and before.
Well, there's a lot that gets left with developers, I think, at times around the security side of things, choosing what tooling or how they're going to put stuff together. And it's the one bit that is not really kind of, I feel there's a gap being left in terms of people spending time and analysing it and looking and making the right choices around certain areas. And there's certain things that you can do by planning with the right tooling that avoid an awful lot of the challenges that come up. I know there's a lot of, security checklists and mandates and everything that are out there now. We had one instance with some developers. We've got a guy who works in our team, Gordon, who's in Taiwan. And locally they're saying, oh, you're going to need to comply to all these cybersecurity rules and checks. And we went through them, and I think half the list was completely irrelevant to us because we are not an interpreted language. And they're like, what do you mean you don't need to do this? I was like, literally, that is completely irrelevant unless you're using these types of languages, and we're not. This is what we are. And this security issue it's a non-starter. It's a non-event because of what we do and the way we do things. So yeah. Anyway, sorry, Antonio, I kind of interrupted you.
No. That's. I mean, there's. I really appreciate your note there, and I fully agree. That all the when we read through all the new security rules, because, for example, when you work with, I speak with customers that are going to work with governments, etc. You can imagine that the list of things of requirements are quite strict. And as Stephen just said, most of the times it's like, even 50% or even more of these requirements are already ticked without you doing absolutely anything. So, as Stephen said, I think we're lacking, or the development ecosystem in general, they're lacking a bit of, okay, we want to do this, what's the best tool? Instead of what's the tool that is the trendiest, because it feels a bit like that at the moment. It's like, okay, what's hot at the moment? Is it I don't know, .NET? Is it Java? Is it whatever? Let's go with that without even analyzing if it's the right tool for the job.
So does Delphi offer any specific features or tool chains that enhance software security over other languages?
Yeah, I mean, the default already, just the fact that you compile the application, just the fact that you're going to have a final binary that is compiled, it's security by itself. Once you remove that interpreted layer from or interpreter in the middle, you're going to tick a lot of security boxes automatically.
Yeah, and then with that said, obviously there's a lot of responsibility on developers, whatever you're developing in. We'd always recommend that you use tools like static code analysis to check to make sure you haven't done anything silly in your coding, like leaving open SQL injection or anything else like that. Or, but then we have a whole load of stuff built into the framework already that even if you did code something in a really bad way, that the components are there to protect you as well. So, for example, our FIDAC controls, which is our database connectivity layer, absolutely fantastic because, again, you just set the components up, set your SQL queries. You can even we've got some great syntax in there that allows you to almost put if-defs in the query. So if it's running onto SQL Server, you do this. If it's running into Oracle, do this. Because there are some variations between different platforms. But the common things like dates and timestamps and stuff like that, we can have those automatically mapped through to make it really super easy to work with. But FIDAC, in terms of the security updates, we've got flags that you can set against the components to say, right, by default, always check to make sure these types of security checks are in place. Make sure it's only a single statement that's run, so we can't have somebody kind of terminate a select statement and then run a delete statement with inside the we're using some SQL injection, those types of things. There's some really advanced stuff that you can put onto the components to help make everything very, very secure. So they're all built in. Obviously, with the compilers, we've got loads of different flags in terms of address space randomization and all the other kind of things that you'd expect to be able to do. You've got total control about when you create and free memory. It means that you literally are in control of everything. From that point of view, it's very, very secure.
Thanks, Stephen. So how does native app development contribute to application reliability, particularly in mission critical or embedded systems?
It's great. Well, as Antonio said, we get to travel around the world and speak to lots of different people, and the breadth and depth of what people are building with Rad Studio is phenomenal. The core of the high frequency trading on a number of the stock exchanges around the world is built with Delphi. I've seen everything from black box recorders to people doing 3D imaging of cow udders to be able to automatically milk cows, which is one of the C++ apps, all the way through to everything from POS terminals interacting with hardware to CRM systems to theatre bookings, both the back end systems and the web systems. Huge amounts of different things built with Rad Studio. And I've completely forgotten what the original question was now, Rob.
It's more about it's just basically about reliability and why you would choose it. I speak to a lot of developers over my times, and a lot of them are using applications that have been running for years. So
and because what we do is connected right down to the runtimes. Windows has done a great job in terms of making sure it doesn't break stuff. Let's be quite clear there. Having both the 32 and the 64-bit compatibility on that platform, and just running is fantastic. And the fact that it isn't a copy and paste, you can literally copy your application that you build on your development machine onto a client's machine and run it. Is phenomenal. It makes it very, very easy to set up and run. Because there's so few reliances on things that are external, it will just copy and go. Now, when it comes to reliability, I think there's actually another part of that question that's probably actually more important nowadays, and that comes down to, especially on the mobile side, connectivity. I think there's an awful lot of times where you need to have connectivity to run mobile applications, especially when they're kind of web-based type of applications. With native apps, everything you need is there. If you need some data connectivity, fine, but having the local access means you can have the ability to cache local data sets if you need to. It means you can have that app reliable and available wherever and whenever you need it. So if you're in the middle of London, down in a basement with no mobile signal, but you've gone for a meeting, or you're going to do an audit of a location, you need to be able to have the data available. You need to have the app running, and having the offline resilience and capabilities of native applications that you can build in, especially with things like IB Lite or Interbase to Go, which is an amazing database, or being able to embed in SQLite if you want to use that instead. There's lots of different choices, and that reliability, I think, is now as much to do about how native apps can make you work wherever you are, whenever you are, with whatever connectivity you've got. So, I think those are the 2 points around that. Antonio, anything you want to add?
I want to add one that not a lot of people look into, and for me is crucial as well, which is dependencies in projects. For example, if you you code, let's think about I don't know, like a Node application or a PHP application, and I'm talking about web services now. The amount of dependencies and vulnerabilities that all those dependencies introduce in your application, it's an absolute headache, because you have to be on a weekly basis, literally on a weekly basis, checking if any of the dependencies you're using has any vulnerabilities. Because of course, a package you use in your project, it makes your life easier at this moment, because you don't have to code whatever library you pulled from these repositories. But then you're going to have this burden for the rest of your life, which is checking if there is any serious bug in that library. With Rad Studio, of course, you can also use get it or purchase or download libraries from third parties. But because you compile the application and it's a binary that it's exclusively that includes all your dependencies built in, you're not going to have this constant feeling that, have I checked this application? Is it up to date? Did I download all the new patches? It's honestly a set and forget scenario when you use native applications. Of course, I'm not talking about leaving that application running for 10 years, but I want to be in charge of when I update my applications. I don't want to be dependent of whatever other developers are doing with the packages I'm using.
Yeah, I think one of the nice things about Get It now as well is that if you are using the Get It package manager, which is a bit like NuGet for those who are .NET people who might know, you'll see if there's updates to it. You can choose when to pull those down, but they go onto your development environment, and there you can check it, make sure it's all good. One of the things that you've got then is you've got that code, you've got that package, it's there, it's part of your build environment. One of the things, going back to what Antonio was saying about package managers at the moment, we've seen, or beginning to see, growing number of instances where people are putting out packages that people are going, oh, that's really cool, they're using it, and then they're changing the license terms for future use, or it's got really popular and they kind of now want to monetize it, so they pull it, or they dramatically change the terms of what's available for anything moving forward on it, and it becomes a real headache, and that kind of constant management of external dependencies can be quite a challenge, which with kind of the approach that we have is mitigated in quite some way.
Okay, thanks for that, Stephen. One common claim is that native apps integrate better with operating systems and hardware. Can you explain how this works in practice with Delphi?
Yeah, I mean, it's because we have access, as we've mentioned a few times, we have access to the metal of the device where the application is running. You can, and I've seen customers creating their own APIs for something very obscure that maybe we don't have a component already developed. So you have access to those APIs. The good thing about FireMonkey, our multi-platform solution, is that we provide an awful lot of pre-coded components. For example, we have a camera component, we have a Bluetooth component, GPS component. The most common set of tools you're going to need for a mobile application, they're very pre-developed for you. And they're, of course, platform aware. You just drop the component, the camera component, you say camera.open, and then you will have the camera available. When you compile that application for iOS, behind the scenes, the compiler will get access to the native API of iOS. Same thing, it goes to Android and even for Windows or Mac OS. So, but as I said, if you want to do something more obscure, you're going to have access as well to the native API and code it yourself. So that's one of the main benefits. Because if you want to use an interpreted, as I mentioned, that this kind of applications that are already a website that you open and it's really a website, then you're going to be limited by whatever the browser lets you have access to, because we have that layer in between. So you don't have access to the metal of the device. I don't know if you want to add anything extra, Stephen, here.
No, I think that's a really good summary, to be quite honest. It's yeah.
Thanks for that. So how does Delphi help developers target the multi-platforms natively without losing performance or access to the device features?
Yeah, I think we kind of touched a little bit on this earlier, but the libraries that we've built, and then the ability to work to a single library, which is then doing the work underneath. So, for example, Antonio just spoke about the camera. So we actually have the camera component, but then underneath the camera component, we have, depending on which platform you target out to, it will then instigate, using the interfaces, it will instigate the physical connection out for the individual platform that you're compiling for. So I think the easiest way to explain it, Robin, is if you think about a steering wheel. If I sat you in a car, you'd know how to use a steering wheel. Now, if I sat you in a boat, you'd know how to use a steering wheel. If I sat you on a tractor, you'd know how to use the steering wheel. But what that steering wheel is doing underneath on a tractor, on a car, are pretty similar, but there's a bit of difference. But on a boat, there's a lot of difference going on underneath. And if you think of the steering wheel as the camera component and those three vehicles as the different operating systems, you just work with the steering wheel as a developer. And we're then taking care of all the plumbing underneath it using really strong object-oriented design and interfaces to make sure that the right stuff is happening underneath it. And that means that we can always make it very easy for developers to connect in and work with any platform. But it also means that any platform in the future that comes along that we want to add on, let's say in 3 years' time, we get a new Wonder OS, which is the most amazing thing since sliced bread, and everybody starts now wanting to work with Wonder OS. Well, the great thing, because of the framework we've got, we can then just build the underlying connectivity, and everything will plumb into the framework and everything that we've got on top of it. So it means the source code that we have and the platforms that we're already targeting natively, we'd be able to move to quite quickly and easily. And especially with the way that we've done an awful lot of work in the last 10 years, 10 to 15 years of making it so you can target multiple different platforms natively from the IDE. It is a real benefit of using Rad Studio, and it makes a huge amount of sense in terms of code investment, because when we're building things and because we've got control over what we do, it means we're able to ensure that we have got a long shelf life in code, and that means that you can just keep on running and keep on going.
Thanks for that. And many developers are obviously attracted to modern toolchains that prioritize ease of use. How does Delphi balance developer productivity with native power?
The libraries we provide and the set of components we provide, you're going to have one code base. You're going to code your application once, and then you will decide to which platform you're aiming for. That's really having the cake and eating it. I'm not sure of that expression. Sorry, but but you get the gist. It's honestly that easy. With interpreted languages, it's true that you have the perception that you're developing fast because you're going to be your application is going to be compatible with all platforms. But at the end of the day, you're going to always find limitations, and then you because it's not as snappy and fast as a native application, and that's a trade-off you need to make peace with if you want to use this kind of languages. But with FireMonkey and Rad Studio, you can aim for those with the same functionality or same flexibility that these languages offer you. You're going to code it once, and then you will really compile the application natively for the platform you're aiming for. So it's an absolute win-win.
Anything you want to add to that, Stephen?
And I think one of the other examples recently is let me give you an example. I wrote an app that got to the top of the iOS and the Android paid sports apps in the UK. My son does an awful lot of go-karting, and when we got going, I needed to be able to rapidly work out what the gearing ratios were for the car at the point of doing setup, and help him understand the differences between the gearing, what it's going to mean on track, and what we're trying to target in terms of the RPMs on the engine versus speed. And so I put together an app. I used a little bit of Skier, because we've got integration for the Skier framework, which is great for some of the visualizations, the animations that I wanted to put onto the app. Kind of got that all put together and got it all working on my Android device. It was looking brilliant. I then just chose iOS as a target. By the time I'd set up the credentials on the Apple App Store, which you'd have to do whichever platform you're working with, plug them in, and then I just hit compile, run. It ran first time straight out onto my iPad. Everything worked exactly as it did on Android. Just looked a little bit different because the native look and feel on iOS is slightly different to Android. And that's what we kind of pick up and use by default. And I had both apps up into the App Store straight away, and all the development work I'd done was just on my local Android device. until the point that I needed to get it compiled and ready to go. So it's literally, the choice is there for you to use whatever you want to use, and it gets there very, very quickly because of what we've got. So yeah, it's really, really cool.
So would you say maintaining a Delphi-based native application is easier or harder over time compared with modern cross-platform stacks?
I've seen so many things over time. I don't know how many .NET developers started using Link. That's just one example of things that have come and gone. There's a plethora of them across time, that frameworks that have come and gone very, very quickly. Obviously, we don't have Flash anymore, Silverlight, all these frameworks that have come and gone. One of the things that is really true with Rad Studio is the backward compatibility of our code. There's very, very little that isn't around today that was around 30 years ago. And the stuff that has come on and come in has all been expanded and moved forward, and providing a host of rich new features that are modern. So yeah, that's the one thing I'd say. The code investment with Rad Studio. If you have got applications, we've still got people who have code that they wrote 25 years ago that they're using in production, and they've moved it up very quickly and easily to the latest versions with not a lot of work. And so, yeah, that is probably one of the big things I'd say.
Yeah. Are there any particular types of industries or projects that are still best served by native development?
I would say that we've mentioned already a few times, each project needs to be analyzed and get the right tool to do or to squeeze the hardware if it's required. Applications where performance is crucial, I would say that it's mental. Sorry, to use an interpreted language. Also, applications where performance is crucial as well. Using a language that has a garbage collector is, again, not a great idea. So if performance is a must, then you need to go native mandatorily. On top of that, then you have to assume the trade-off that you're willing to offer to your customers. If you don't mind that your application is not going to be as snappy and as fluent as a native application, then you need to make peace with that. But if you want to offer the top-notch performance to your customers as well, and you want them to use the minimum resources possible in the computers, then you need to go native as well. Coming back to the example I was talking about earlier about Electron applications, it's not rare to see a very simple Electron application that uses like 0.5 gigabyte of RAM, which is ridiculous if you ask me. That application native could be, I'm just ballparking here a figure, but it could easily use like 50 megabytes instead of 0.5 gig. So that's also something that not a lot of developers are thinking about, saying, okay, how resource hungry is going to be my application if I go with this technology? Because it's true that we're having more and more powerful computers and devices, but that doesn't mean that we're allowed to just ask our customers to have or change their computers and devices just because our application is not properly optimized.
Yeah, and I think the whole thing about scalability, we've seen a lot going on with AI at the moment. We have the Delphi to Python bridge, which is fantastic. It allows you to be able to use Python script and call those directly from Delphi code. There's some great Python libraries out there, especially around AI, and you need a wrapper to kind of access into those. Great fun. Well, we can go call those from a native application quite happily. And also have a bridge back into the Python scripts to run and use the benefit of native application performance. So we've got a very strong parallel processing engine within the libraries that we have. We have all the benefits of object-oriented development. I was chatting to one guy, a doctor who works within the AI area, who's been doing some really cool stuff and was looking to train a lot of different models. And one of the big problems that he was saying there is that, being able to actually implement models and get the work done with them, you've got to do the training and then check the result afterwards. And it's very hard to tell early on if it's kind of going the wrong way on the curve. You could, if you had the data, you could spot it. And he actually started putting a hook back within RAD Studio to use the object-oriented program models that we've got to analyze data from a model that is mid-training, and then being able to go, well, this model's going in the wrong direction. Let's kill it rather than having all that compute processing time taken up. Let's reset the variables and run again. And that's a really powerful view about how augmenting some things that are maybe not running in native code, but you want to have the power and performance around it. Also, we see a lot now with AI, with people developing, with Python, and then kind of getting their POCs done, and then going, right, well, now we've got this working, we need to now make it market ready, which means improving speed, performance, and reliability, and then taking some of the processing and moving that out of the Python scripts into native code. And that's where those kind of bridges really comes in to be a huge benefit. And because Delphi is very easy for people to pick up and learn, regardless where you're coming from. It means being able to pick up and do that kind of stuff. We see a lot of people within mathematics and engineering who may not be developers first, who pick up and use RAD Studio because it's very easy for them to get that benefit as well. But then on the flip side, we've got people who are highly evolved software developers who are building stuff with RAD Studio because of the speed, performance, and the reliability that you get with it. So the accessibility to develop with RAD Studio is very good, which helps any industry who's looking to pick up and get the benefits of native performance. It makes it very possible for them to do that with our tools.
Yeah, that moves nicely onto my next question. Are there any notable products or companies that are still using Delphi that people might not be aware of? As a bit of a geek, it's always nice to get some really good examples of applications that have been written.
Oh, there's lots around the world.
Can you share any of them with us?
Well, I say I've given some kind of indications to where things are. There's a huge amount that we've had around kind of everything from first responder units. I've worked with people in the Nordics who are programming and managing everything that goes on around a police car and the radios and the systems and all that kind of stuff. There's a huge amount in healthcare. There, if you ever go to kind of the airports, there's a lot of the security systems there have got either Interbase or Delphi technologies embedded into them. There's it literally is every walk of industry you could think of. There's stuff out there. I've done stuff, say, with the London Stock Exchange, with South Africa, with POS systems. So many of those types of things. Literally everywhere and anywhere. We mentioned theatre booking systems earlier. One of the biggest theatre booking systems is running Delphi application, managing all the theatres and everything underneath the back of it. Any fun ones that you can think of, Antonio?
I wanted to say that in our website, because this is always a sticky topic, because I could mention quite a few, but privacy wise, I don't remember if I can talk about that customer specifically. So what I would recommend anyone that is interested is going to our website. We have a section with success stories, and then you can see the actual names of companies that were willing to share their experience and how they use our products successfully. I can think about one that is in the website, that is FL Studio. Is a very, very popular DAW. That's the name of a music production environment. And I can promise you that if you've listened to music in Spotify or any streaming service that has been produced using FL Studio, like 100% sure. And that's just one of the examples. As Steven said, is used in pretty much any industry, and we use this term that Ian Barker or Marco Cantu use as well, which is Brad Studio is quietly successful because we're pretty much in all the industries, but it's not like you're constantly going and talking. We use Delphi, or we use C++ Builder, but we can promise you that it's used in thousands and thousands of projects out there.
Yeah. Well, to give you some of the names on the website, actually, because that's a great prompt, Antonio. I'd completely forgotten to look on the website for the names that we've got up there at the moment. But there's Dell, Honda, John Deere, Motorola, NEC, Nintendo, Panasonic, Sony, SoftBank, Pfizer, Toyota, UPS, Western Union. It is used all the way around the world in a broad set of areas.
So do you think that then that native development will grow or shrink in relevance technology evolves, especially with trends like low code and PWA and the cloud?
I think the drive always from any of these technologies is to try and get as native as they can. And I think the trend in the market, they always try to talk up whatever native capabilities they've got because of the key points that we've been discussing today. That speed and performance, the security, the reliability, the deep system access. The fact that we've got all of that built into what we do and we've been doing it for so long shows above everything else that we've got this longevity and proven tools to make that kind of investment work. But yeah, I think native is a really, really important paradigm because, and especially with the growing need around scalability, and I think we're going to be seeing more of that with the whole AI emergence. To get the best out of any device, it's going to be as much about what you can do with the device that you've got in your hand as calling back to remote servers, because you need to distribute that compute and have that as close to hand as you can to get the best speed, performance, and reliability. And we're already seeing kind of Android pushing out a lot more around its AI capabilities about what you can do on device. So being able to tap into the APIs on the local device to service your applications with the capabilities of that physical device is really important. So yeah, native is definitely the future.
Yeah, and I also want to add to that if we're moving now to the server side of things, so if we think about because I mean a lot of customers or a lot of users are starting to use cloud services, AWS, Azure, you name it. It's not the same if you have a service that is going to use 30, 40 megabytes of RAM and it's going to use, I don't know, 20, 30 megabytes of a space than an application that is going to use 400 megabytes of RAM and the space is going to be 200 megabytes. Once you start scaling that is when you start noticing, okay, maybe we chose the wrong technology, because the invoice at the end of the month is going to be dramatically different if you're using native or you're using an interpreted language. And and also because of the environment of things, the less resources your application uses, the greener it's going to be. It's as simple as that. I mean, of course, money-wise, it's going to be cheaper, but again, the less resources you use, the less money, hence the less impact as well in the environment.
So I'd say that one of the most important things is just to be aware. Some people talk, oh, well, this is old or that is new. Java is older than Delphi, I think. There's Python is older than Delphi, I think, was it? There's a number of languages that came out around about the same time, and don't get kind of caught up with somebody saying, "Oh, this is new technology, that's an old technology." I think the most important thing as any young developer is learn the basics, understand what object-oriented development is, understanding what the core principles of design are, and I'd say probably go out and learn the industry or get some real experience of what you're trying to deal with. Talk to the customers about what you're trying to create and go for, and then get on and develop. Now, obviously, choosing Delphi, once you've learned the basics and the foundations, you've then got the chance to start getting exposure to the different platforms. There's so many platforms out there. If you start trying to choose one language to get across each platform, you're not going to have the time to become a master at any of them. So tools like Rad Studio and Delphi make it very easy to do that. A lot of the principles are very similar from language to language. There's only so many ways you can make a wheel, and we've seen a lot of that over the years. There's a lot of paradigms. I know, obviously, from the work that Ball and back in the day did with Java tools, trying to get the objects structures very similar across there. Obviously, .NET coming from the same father as who originally wrote Delphi. The frameworks that you're going to work with are going to feel quite comfortable. So don't be scared about having a jump in and playing with something different. I think that's probably the most important thing. And I'd always say just have fun with what you're doing with the development point of view. When you're having fun with the development, you're going to end up being a better developer for it. So that would be my advice to a young developer today.
For me, just adding to what Stephen just said, I know it's very, very appealing or very easy to just go with the trend and think yes, because at the end of the day, we all just want to fit in. I mean, we're all like a bit like sheep. But what I would say is try it. I mean, make your own decisions. Rad Studio, we have a trial that you can download for free, and you can use it for 30 days. And we also have the community edition, which is free to use if you're compliant with the requirements of the community edition terms. But just try it. A lot of people get surprised once they try our solution and they think, well, this is not what I've been told it would be. I thought this would be, it will look older, or I've heard that this is a legacy product and I can do all this amazing stuff. So just try it. I mean, that's the easiest way or the best way to know if something is for you is just trying it.
Okay, I think that about wraps up our episode. Thanks, Stephen, and thanks, Antonio, for joining me today. We've certainly covered a lot about native app development and its benefits, including the speed, performance, security, reliability, and longevity of the product.
Yeah, it's been a great session. Thanks for hosting it, Robin. And I think just one last thing I'd mention, actually, Antonio's helped drive putting together a really good book for developers who are new into Rad Studio. So if you do download the trial, within Get It, there's a couple of books that are there that are promoted to help you get up and get going and help you get a broad orientation to the different frameworks and what's within Rad Studio. So that is definitely the best place to start. And as you get on and get going, obviously feel free to reach out to the guys at Grey Matter, or feel free to drop Antonio or myself an email just to say hi and let us know what you're doing with the projects. We always love hearing about what you guys are doing, and look forward to welcoming you to one of the events that we've got with Grey Matter in the future.
For those of you listening, if you do have any questions for me or the Embarcadero team, you can email us at info@greymatter.com. If you're not familiar with Grey Matter and what we do, we're a software and cloud service provider that helps businesses maximize opportunities and solve challenges. We've been an Embarcadero master reseller since 2008. And thanks for listening, and don't forget to subscribe or tune into future episodes. We've got lots of exciting topics, including app modernization, data science, and cloud technologies. Bye for now.